Okay, then I think I can share my screen now. Do you see my screen?
Yes.
All good.
Yes.
Nice. So, hi everyone. I will present what we are currently doing and actually almost finished in the implementation regarding the trust anchors management. So this will be a pretty, I guess it should be at least a pretty short tech deep dive. But still could be interesting if you want to know how we currently manage this kind of stuff in V1 and how we will manage it in V2. So as a disclaimer, this is all nothing that you will see today will be backported to V1. So this does not impact Tagus in any means. So how do we manage trust anchors now, and how will we manage it in the future? So currently, we have one service of our compliance engine is the registry service. Philosophically, this service is meant to serve artifacts, whether it's trust anchors or the ontology, for example, to the compliance engine and other services. So it was never intended as something big, because actually its only responsibility should be to provide the artifacts. As of right now, in V1, the registry service also has the responsibility to fetch the SSL and eIDAS certificates list from multiple sources. We get the SSL certificates from the Mozilla certificate program, and the eIDAS certificates from the European Commission and the countries' APIs. So this is the first step. We will see, the first step in the trust anchor management in the current registry. We also fetch our own Gaia-X association certificate on GitLab, which is not ideal because obviously it's quite junky. Then the registry service needs to parse and manage those lists, which is not trivial. Actually, it's quite a large part of the code, because they are not standardized in their formats. And then we use MongoDB to store the extracted trusted anchors in the registry. So this is one deployment of Mongo, which lives alongside the V1 registry, and then stores all the certificates, SSL, eIDAS, and Gaia-X association certificates, so that the registry can then check against those root certificates to issue or deny when asked for verification for issuing a Gaia-X compliance credential. So that's what it currently looks like. We have the registry service on the left, which, as I said, fetches the Mozilla SSL certificates. It also fetches the eIDAS certificates list. We parse those lists. We fetch the Gaia-X ISBL certificates from our GitLab, and then we create our own non-standardized kind of data structure, which is a list, first in memory, and then we push this into our MongoDB. So it's quite efficient in the sense that it's simple, at least on the first look. It's definitely simpler than what we will have in V2, but it also presents some challenges. So the first one, and the most important one, I guess, scaling the system to accommodate more trust anchors implies registry service updates. So if at the moment we have, as I said, the SSL certificates and the eIDAS certificates, and the association certificate. If we, for whatever reason, whether it's to be compatible with other countries external to the European Union certificates list, or to revoke, for example, the association certificate because we have issued another one. Any simple and predictable operations like this would require to update the registry service, which is problematic because the registry service services actually are deployed by multiple clearinghouses. So let's say we add another list or another certificate to the trust anchors. We have to make sure that all the GXDCH providers update their registry at the same time, or more or less at the same time, so that compliance is handled in the same way by each clearinghouse. So this is obviously an issue in terms of scaling. The lack of standardization in trust anchors list, so this is pretty self-explanatory. We have our own data structure and then we store in Mongo. The performance burden of the MongoDB while we have the IPFS infrastructure. So in V2, not in V1, but in V2, we already have deployed the necessary infrastructure to do what I will show you just after this. It makes sense to use this, for which the performance cost and the operational cost is already sunken, and not keep the MongoDB alongside. Centralized management, so this is also pretty simple. We have a single point of failure in the registry and MongoDB. If either one of those two have bugs or an issue, we cannot serve anymore the trusted list. No one can look at the trusted list. So this leads to an increased risk of downtime and unavailability. And then this is more for us because I'm speaking about code maintenance, but it's an increased code maintenance burden on the registry service for us. So what are ETSI 119, 612 trusted lists? They define a standard format for creating trusted lists. So we want to use something that has been standardized and defined, even if it's obviously not as simple as what we were doing before, which is basically having a collection of certificates objects inside Mongo. Those lists contains metadata about the list, so the version, the issuer. Here it's the Gaia-X association as the issuer, for example. Detailed information about each TSP, so in our case, the trust anchors. The status of the TSPs, granted, withdrawn. This is useful because we can keep some history. The one revoked TSP would not simply disappear. We will see the status has changed. And typically, well, actually, it's required, I think, by ETSI, but it's signed using XAdES. The benefits, well, it's consistent. It's standardized and defined by not by us, but by ETSI. It's a clear and verifiable list of trust services, and it's protected against tampering and modifications. So if you, obviously, we have responsible GXDCH providers, but if you were to imagine that someone wants to modify the registry or manually insert inside his clearinghouse, his Mongo, whatever certificates he wants, then this specific registry would be able to validate against this certificate, even if we, as a whole, do not trust this encore. This is not possible if the list is signed, obviously. The XAdES signature, this is a framework for creating electronic signatures on XML. It contains pretty mandatory information and necessary information. So the canonicalization method of the XML, the signature method algorithm, the digital signature, so the signature in itself, and the information about the signing key, the public key, the certificates, etc. So this is pretty standard. Although it's not as easy to sign with XAdES than with whatever other method, because it's more constrained, but there are libraries already that exist and do this very well. The benefits, classic signature benefits, integrity, authenticity, non-repudiation. So about what I was talking just before, and someone tampering with the trust encores in the V1 registry. This is not possible anymore. Required signature method for the ETSI 19612. So, well, it's required. So we will use it, obviously. The details of the new implementation, so the one that will be coming in V2, we have a new service, the Trust Encore service. So the V1 registry was polluted by this second responsibility of managing the Trust Encore. This one is single responsibility. Its responsibility is to manage the Trust Encores. So it does the same thing that we saw for the registry. It fetches the Trust Encore list from the diverse sources, and we can it will also host the Gaia-X certificate. So we will not fetch this certificate from GitLab anymore. It parses and aggregates the Trust Encore data. And that means it creates an ETSI list. It pushes the list to the IPFS pinning service, which is already existing in our implementation of the V2 clearinghouse. And it's built with Nest Commander. So Nest Commander is the CLI version of Nest. Basically, this is a service that will run at some interval, determined interval. We are fine with something headless, so we use Nest Commander. The ETSI 19612 and XAdES library. So this part is creating the list and signing it. So you can imagine the input being a list of certificates and the output being an ETSI list signed with the information of the Gaia-X association, signed with a XAdES signature. And this will probably, most definitely, I guess, be pushed on NPM as we already did with some of the signature part of our compliance services. And then the IPFS pinning service and DNS integration. This has already been presented in a previous tech deep dive, but it manages all the IPFS infrastructure necessary to seed and advertise the artifacts needed by the compliance. So we have, at the moment, it does this with mostly deontology and the revocation list, but we are adding the trust anchor. And actually, in the current architecture document, we already have specified the endpoints for the well the way the gxdch.eu DNS will advertise the trust anchor. So the details of this implementation, we have the new service, which is the trust anchor service, which fetch the certificates, Mozilla certificates, SSL certificate list, European Commission eIDAS certificate list. So this has not changed. Same as before, we parse everything. This has changed. We lose the external GitLab dependency, and we load local certificates. So at the moment we will have the association certificate, but we can imagine that we want to, or need to add more specific trust anchors. We use the new ETSI XAdES library to create the list and sign it. We push the signed list to the IPFS service, and the IPFS service does its job in the same way that it did with the deontology. So it will first check if the files have changed. If they have changed, then it will update the DNS TXT record with the new CID, provide this into IPFS, pin it, make sure that it pins it regularly so that it's not garbage collected by IPFS. And then the registry service, which is in this version, which has lost all the trust anchor parts to the trust anchor service, will in the same way that it does at the moment for the deontology, it will read the DNS TXT pointer to fetch the trust anchor list. With the added benefits that it has lost the MongoDB and the list is signed. So obviously we are sure that the list is correct. So this is just to show that everything in orange we already have. So this is not how can I say, added bloatware. It's something we already have on V2, on the development of V2, and which is used to share the ontology. So no additional operating cost, no performance cost, etc. The benefits. So architecture is designed to easily scale. If we want to add trust anchor source, and we won't require gxdch providers to update their registries if we manipulate the trust anchor. So obviously everyone will be aware that we are manipulating, changing, adding, revoking the trust anchors, because this is public on IPFS and publicly advertised by the DNS, etc. But so we do not lose the accountability, but we do not require an additional workload from the gxdch providers anymore. The obvious IPFS storage advantages, so no single points of failure, decentralized, distributed. Adherence to ETSI and XAdES standards ensures legal compliance and interoperability with eIDAS regulations. So eIDAS requires XAdES signatures. Single responsibility service, so it's simpler in terms of purely a software development philosophy. So it reduces the maintenance burdens for the association or the open source community if the open source community wants to work on the registry. It uses the existing IPFS Kubo node, which is deployed on V2 alongside the registry. So this node is used to connect to the IPFS network. It's addressed by RPC calls by the registry. And so this we already have for the ontology, and it's not an additional performance cost. And then we remove MongoDB deployment, which is not hugely, which do not have a huge consumption, but still it's because we do not store a huge amount of objects, but still it's a Mongo instance, so it can be it can eat some RAM on the GXDCH cluster. So overall, we will reduce the GXDCH requirements in resources. And the new Trust Anchor service is managed by the Gaia-X ISBL, at least at the moment, because we do not have, even if we can imagine that in the future, we could have decentralized governance and stuff like this. We do not at the moment. So it's less operational cost, workload and cost for the providers. And we achieve less operational cost by taking away something that they had nothing to do with in the first place. So something that does not add any value to the clearinghouses. So overall, it makes sense that they don't have to manage something that adds no value to the complaints. And I guess that's it for me. So if you have questions, go ahead. And if not, you can reach up to me on Slack or the team, and with our usual communication channels. Okay, so I guess it was clear, or so unclear that no one has question, or clear enough that no one has question. But you can send me a mail, or if you have concern or stuff like this on my Gaia-X email or on Slack. And I guess good afternoon. Yeah.
Arthur, there is
Yes?
one question from Eric Lavella about the trust
sorry.
anchors.
Sorry, I didn't. Yes, the chat. So yeah, the Trust Anchor service, well, it does not exist yet. It will be mentioned in the. It will be mentioned for sure in the docs, but I'm not sure it has to be mentioned in the architecture document more than what it's mentioned at the moment, because it's an infrastructure piece that's not really relevant to the Gaia-X architecture. What's relevant is how, in which format and how we share this to the registry services, and this part is already updated in the architecture document. Internal service of the registry. So now the registry needs those artifacts, but I mean, if I want to build myself the ETSI list and sign it, and then I provide it to IPFS and advertise it on the Gaia-X DNS, then it's all the same for the registry. I mean, the service is not really, in my view at least, relevant to the Gaia-X compliance. I'm not sure if it's clear, but of course you can disagree with me on this.
And Mr. Henderson, if you still have the question, you can just ask, you can just unmute yourself and ask directly or write in the chat as you wish.
Okay, perfect. Can you hear me? Yeah.
Yes.
Yes.
Okay, thanks for the presentation. So, so my just one doubt regarding the registry which you are using. So, is it the trust list which you showed? Are you using the same ETSI model, or you have planned to include some additional attributes to support the Gaia-X for in terms of policies and contracts and things like that? For example, because the current ETSI model is based on X509, the architecture or the legacy systems. And it was also published in 2014, for example. So do you have any plan to foresee to include any extra, for example, because in Train we worked on to include a additional registry, which accommodates also the credential types and also, for example, the DIDs and things like that. So if you would also like to look into that direction, we would also be happy to support. For example, it's an additional extended version of XML trust list on ETSI. Yeah.
I guess for what we are doing right now with it, which is making basically simplifying a lot, but making a list of root certificates, I guess we are fine with the existing list. But and we do not extend on this. But this is because we are only using this at the moment to manage a list of certificates. So, but yes, I'm interested to look at what you just said and see what you are doing on top of that.
Okay, sure. Thank you.
So I'm reading what you.
Oh, yes, I have one question regarding you say you want to you provide a central resolver, or and why this is not decentralized installed. What you every time do is nothing more as you will retrieve the trust list from different sources, make a common common model, and then you validate against this common model. Why you need it in a central storage or a central?
Because the ASBL is still responsible for the list of trusted anchors. We are not just fetching anchors from everywhere. The ASBL must be in charge of the trusted anchor list. So that's the reason we have a centralized component that will fetch the list, will be updated maybe with the Japanese eIDAS equivalent at some point, or the Brazilian, but this is still managed and operated by the ASBL. We are not just trusting everyone or anyone. We are just changing the way we had implemented the trusted anchors recover. That's it.
Yeah,
that's the reason we still have a centralized component.
Yeah, and that's why also we are separating the part with the building of the list from the fetching of and fetching of the certificates, because at the moment this is pretty the assembling the certificate list is pretty dictatorial by the ISBL. Building the ETSI list and signing it should be separate. If ever we come up with, or actually our members come up with a way to democratically in a decentralized fashion select and vote or govern the trust anchor list, then we do not need the first part of the service, which is the Gaia-X trust anchor service, and we only need to do something great and decentralized and use the small libraries to build the list. This would be nice, but it's not the case at the moment.
And also this enables the discoverability of the trusted anchors provided by the association. We inspired ourselves from the train initiative, except that we are using TXT records. And if you try to dig a TXT record for development underscore development should be underscore trusted anchors.jxdch.eu, you will be able to get the IPFS CID of the trusted anchor list, meaning that you can import it in your project or do whatever you want with it. And that's what the registry will use to fetch the trusted anchor list during the startup, instead of pulling Mozilla and the list of trusted lists from the European Commission, and maybe tomorrow Brazil, China, India, or whatever country list of trusted list.
And one question more. Isaac mentioned that also. Is it not required each federation or ecosystem have in addition his own trust list? What you have is you have Gaia-X trust list, and you have to trust Gaia-X and the ecosystem from Gaia-X. Now you build your own ecosystem like Catena-X, and they have a different trust anchor in addition. And this is against typical. And then they need also an implementation to resolve and manage the trust list and the trusted issuer of some credentials. And you can say my ecosystem can in addition have a trust list, and we only accept automotive provider in European Union. That means I have to manage my own trust list. I cannot send that to the central Gaia-X. This is my ecosystem. And now I need to combine both. And have you any ideas how you can do that?
Basically, I would say that this relies in your ecosystem. Gaia-X gives a global compliance scheme and compliance rules. If you have other rules on top of Gaia-X, that means that after your customer, your service providers have issued their Gaia-X credential, you have to do the job of excluding them or not allowing them in your ecosystem. Maybe with your own instance of a registry and your own trusted anchors, but the Gaia-X trusted anchor list is quite fixed and decided by the members. So, and this also means that if you have like this reduced scope, or if you have trusted anchors that are not in the trusted anchor list of the association, and you try to push credentials in the compliance engine, it won't work, and that means that you are not compatible with Gaia-X.
Yeah. What I want to do is to shrink it down to a subset of it. And what I don't want to have in my ecosystem have a proprietary implementation. And if each of the ecosystem implement his own mechanism for his own, you repeat yourself, you know it. And it would be great to say, we have here the Gaia-X trusted list, and we are compliant to Gaia-X. Then we use this service, and the same service I can use locally. And when I will only call one, and this is in a chain, he call yours, and I call my, and then I have my local rules, my local trust list. This is a subset of that from Gaia-X, and then it's a uniform trust resolver across all the ecosystems. This is a little bit in mind what I have. And we have often discussed that, and we see a big need for that. And not only to see you are compliant to Gaia-X, so the automotive, you can also do health, issuing health certificates. Yes, you are Gaia-X compliant, so you have to trust them. No, you can't trust them. You can only trust them when you are in the health certificate, have a health certificate or automotive certificate. And that means you need to have a chain, only extend your chain to an addition. And there I want to use the same software and the same approach, and not implement it for my own ecosystem. This is the thought behind it.
Well, right now the registry is not able to do it, but you are like the component is open source and you can propose a merge request on it without any problem. But yeah, right now the component is fit our needs, and yeah. But yeah,
Yes.
feel free to open a merge request on it.
Also, the part of so the registry code would need to be updated, but the part about the IPFS DNS registry interaction, this has been designed to be extended by the ecosystems. So I will link the relevant part of the architecture document. But basically, if you make it so that the registry, our registry, or your own registry points to your own DNS, and you use the same format of advertising a trust anchor list, an ontology, etc. Obviously, depending on what you will do within the list and the ontology, you might not be Gaia-X compliant anymore. But if you extend this for your ecosystem and you use the same advertising mechanism that's described in my link, you should be fine.
Okay, I will have a look on that. Thank you.
Yeah, I have a follow-up question actually. Yeah, one question. So I just see that registry you are mentioning with versions, right? So for example, based on different version 0.4, 0.5. So how are you planning to do this in the credential side? So are you planning to include this because when you see a credential issued in different type of version, for example, how do the registry or the system recognizes that, right? Because when you store different records at the same time, it will become 100 or more number actually, but when you're not including in the credentials, so how are you going to recognize that and how it's going to be handled?
I'm not sure I understand your concern. So when you speak about version, you are talking about version of the compliance services. So
yeah,
when I say
compliance
V1,
trust
V2,
list. Yeah, exactly. It's a trust list. I mean, the IPFS list which you are attaching in the
okay, so
DNS,
the
right? So
ETSI list, right?
yeah, exactly.
Yeah.
And so when a credential is issued, for example, 5 years back, which was in version 0.1, and now it's the 1.0 is the latest version, which is currently used. And how does
if the trust
credential is
anchors
being,
have,
so who's responsible for verifying it? Because, for example, in terms of use, do you have any attribute where it is mentioned?
I guess the consumer is responsible for verifying it, but in your example, your credentials should be expired, I guess.
No, it shouldn't be expired because.
Shouldn't it?
Yeah, because the list gets updated when there is a new person comes, right? So when there's a new person enters the list, then the list gets updated automatically and the version also. But the old person in the list remains the same, right? So for example, if an automotive federation which was enrolled 5 years back, they are going to be same in the federation or in the list, for example. And how do you reference this to the latest list, or is there any mechanism to reference to the past list, or how do you handle this?
I'm not sure, actually.
If I may, it just maybe answer maybe a way for a credential. If you get a credential and then it gets verified by the compliance, then indirectly, it will be checked against the list of trust anchors, and then you can use that compliance credentials to say that it at some time it was compliant and therefore it's coming from a trust anchor. So you can also use the compliance credential that way. I don't know if that answers the question. And in the compliance credential, you have the version of the ontology used, and also you have the date of issuance from the compliance credential.
Okay. So in the compliance credential, there is okay. But is there any specific, or it is mentioned in the sharp shape files, or how does it handle actually, or is the version of the list used is being mentioned somewhere? For example,
It's
the
not
ETSI
actually,
list, right?
but
For example,
I think we are talking about different versions because we have the version of the ontology, but
okay.
if you mean the version of the trust anchors, we don't include anything like this in the compliance credential. At least I don't know the compliance credential by heart, but I don't think so.
Okay, so it's always then referenced with the latest version of the list, right? So somehow the verifier need to know the latest version of the list, because when there's a new update happening in the DNS, the verifier also should somehow know what is the latest version, right? Because otherwise there also needs to be some API calls happening between the verifier and the DNS, so that it has the latest update of the list, for example, which it needs to refer to. Otherwise,
Yes.
there will be okay, so it is
Yes.
being done. Okay, so if there are multiple verifiers deployed across organizations, then they would be notified, or the resolver component which you have that automatically updates.
Yes. Okay. I think I understand your question now. So yeah, we at the moment our compliance engine, at least, which is the only one, I guess, the only implementation there is, regularly, well, multiple times, 6 times an hour, checks for the DNS to see if we have a new version of any artifacts that are shared advertised through their CIDs on this. So we should be, and all the clearinghouses should be, their registries should always be up to date and look against the latest trust anchor list, the latest ontology, well, the ontology that you selected, and so on and so on. So at least at the moment, we did the DNS advertise the last version, but not but the registry makes sure to be updated, up to date.
Okay.
One question: how you send the requirement to validate in the past? Sometimes you have a certificate or document, and you need to know who was trusted at that time as last year. And this is often the case if you have a regularity and say, we have here data I have to trust. Was the trust at the time? You say no, you don't never have this. We have it in the law that's in Germany. I don't know the French law. We have the law to validate at the time being, and not at the current time. The huge is every time in the future and not at the time it happens. And you have to make the proof at the time it happens. So you need to know exactly the time where was the trust. And if you don't have the version, it will be very, very hard to validate that.
That's a Gaia-X compliance credential you are describing. At the time it was issued, you were compliant and you were trusted. And you have the date, and it's valid for only 3 months, so it's quite short-lived, meaning that if you are not compliant anymore, your certificate won't be valid and you cannot get a new Gaia-X compliance credential. But that's basically a Gaia-X compliance credential you're describing.
If I may jump on that, this meeting is a technical deep dive. So if there are new requirements on the legality of the credentials, that should be a requirement coming to the policy rules committee. So if Bert, you require, for example, the timestamp to come from a qualified timestamp issuer, then this is not a requirement for us here. That will be a requirement from the policy rules committee.
Yeah, that's true. Yeah, we have to discuss that in the policy and rules and to solve that. It could be solved in a versioning, and it could also be solved in the in an audit way. You can also say there's an audit and it was validated at a time being, and I trust the audit. This is the normal way what you do, audit, or you have a versioning. This is
and you have the audit by the Gaia-X compliance credential because it's time time-stamped, and you get it because at the time it was generated, you were trusted. So you already have this mechanism. It's basically a Gaia-X compliance credential. And if your ecosystem is using them, well, you know that when the credential was issued, your participant, your service, everything was signed using a certificate that is trusted. If you are using the original VCs, well, that's another problem. But we do encourage people to use the Gaia-X compliance credentials to exchange data and then to retrieve the original VCs and etc. And there is even a mechanism to see if the original VC was tampered or not. You have this integrity hash and everything. So I think we already covered this. And if it's not already, yeah, feel free to participate in the committees and working groups, because that could be a nice requirement for us to address.
Yeah, and also it could be quite simple actually to store an history of content IDs, which are hashes of the list, and we just have to, well, at least at my pay grade, we just need the requirement and the specification. Okay, so a lot of feedback actually. Thank you very much. If you feel like I didn't understand your question or we jumped off too quick, feel free to get back to us, send an email, and be sure that it won't be lost. With any concerns, legal concerns, etc. And thank you very much for coming.
Thank you, everyone. Have a nice afternoon.
Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.
Bye.
Thank you.
Bye.
Thank you. Bye.
Bye.
Bye-bye.